My name's Ethan. I go to the Bay School of San Francisco, and I'm a rising senior, and this is my metal detector so far. So I started out with a circuit that I found online a couple days ago, and after building it a couple times, I wasn't having any luck with it. And after looking at some of the comments on the tutorial, I realized that no one else had luck with this circuit either, and it was in fact not complete. So that was disappointing, but I jumped to a more reputable source and rebuilt it using that circuit. I started off with knocking it out on a breadboard, and it worked first try, which was really cool. I then attempted to move it to a solderable breadboard in order to not be able to rip out components or just make it much more permanent. Had a bunch of trouble with that because I just had trouble rebuilding it. And so eventually I thought it'd be much more effective to just leave the wires how they are, not shorten them, be able to trace where they are, and just keep it that way. So that's why it looks like this. After building it successfully, it works, and I was happy about that. But it was not very sensitive, so I changed to a larger coil, which has made it better. I might change to a larger coil still, make it more sensitive. The entire circuit revolves around the NE555 chip. It's the most popular chip produced in the world still. It's essentially a timing oscillator. Oscillates at 8 megahertz. And those oscillations are what make the tone that the buzzer plays. When the coil gets interference from a magnetic source, it either is more effective or less effective. So, for example, when it has the solder on it, which is a coil in itself, it's more effective, which makes it a higher pitch when you go past it. That then goes to this chip, and it basically increases the effectiveness and makes the oscillations easier, which oscillates a higher frequency and makes the buzzer play at a higher frequency. When it has a non-coil object, it is made less effective by the non-coil nature of it, which makes it much a darker frequency. Much slower frequency. That is then harder for the chip to play and makes a lower frequency. After the IC puts out that frequency, these two resistors make it into tone it down to a more human audible level, and these capacitors turn it into a voltage range. This buzzer then gets voltage anywhere from 0 to 10 volts, and that voltage then it's never gone up to 10, but it can changes the tone.